risk, how it is initiated, that is interesting story. That the chairman of JP Morgan's one day walking through the office and asked that a single number be made available to him every day that is about firm risk. From that day, this value at risk is reported by many mutual fund managers, financial institutions, and portfolio managers. Now, what is the value at risk? It basically provides a single number for the risk for different financial assets of trading portfolio. Now, there are different methods to calculate value at risk. Here, I will explain 10 different methods and 20 different ways to calculate value at risk. The first one is the historical value at risk. It is also called probability value at risk or simply p value at risk. It is basically a non-parametric approach. Now, how we can get this historical value at risk? For example, from live data, we have, let's say, stock price data, and we want to calculate the value at risk for single asset. Now, after getting the stock price data, we calculate the returns. Now, for example, we have 100 returns. With the help of count function, we will get this number, and then we assume that 5% probability. So we multiply this 5% with this 1000 returns, means this 1000, we will get a fifth or five number. So it suggests a fifth position of the data. Now, for this, we should have sorted data. First, we sort the returns, and then we will get fifth position. So this fifth position will give us value at risk in percentage. Now, how we can get this? This can be get manually, or you can use small function, or we can get it with the help of rank function. First, we will use sort function, then rank function, and even very simply, we use the percentile function. Or we have other two functions like VLOOKUP or XLOOKUP. So these are five different ways to get this historical value at risk of a single asset. Now, the second method that is called a parametric approach, and it is also called delta normal method or Gaussian value at risk or Gaussian method because it's based on normal distribution method. Now, if we want to calculate it manually, then we should have a z value like at 5% level of significance, that is 1.96, or we can get it with the help of norms inverse function in Excel. Now, as we have the returns data of a financial asset, we calculate its standard deviation and then we multiplied it by this C value. We will get the percentage value at risk, means the value at risk in percentage. Now, there is a little variation. The first one is a relative value at risk, and the second one is absolute value at risk. Now, in relative value at risk, we just ignore the average return. But in absolute value at risk, we also take average returns as well. These are added to the this relative value at risk. In absolute value at risk, as we have, for example, if we have longer period, then we should account to this average return as well. Now we have again historical conditional value at risk as well. Now, how we can get this historical conditional value at risk? The number or the positions that we have obtained in this first method in historical value at risk. Before that number, we have also some negative percentages as well. So we take the average of all these negative number before the suggested position in this first method. So this method is called conditional value at risk. We can get it manually, like I was discussing that before that position, we just take its average, or we can get by using different Excel functions like average if function or sum if function, or with the help of average and filter command as well. Now we have another method that is called parametric conditional value at risk. That in second method we have calculated this parametric approach, and we have also conditional value at risk for this method as well. Again, the same procedure that we have adopted earlier. Most of the time, we know that our data is not normal while calculating our returns in different frequency data like weekly or daily data. Uh, then we have skewness and kurtosis problem as well. As in skewness and kurtosis problem, to tell with those problem, uh, Cornish-Fisher introduced a new method that is called Cornish-Fisher adjusted value at risk. In the first method, skewness is adjusted, and that is called adjusted value at risk, where we just calculate simple value at risk. Similarly, we can calculate conditional value at risk that is also adjusted for skewness as well as for kurtosis. Uh, the difference is only is that the value of z. Now the value of z is calculated with the help of this formula, small z sk, and then we have some lengthy formula. It's just like Jarg-Bara test formula in which skewness and excess kurtosis are adjusted. Here also the skewness and kurtosis are adjusted. And for conditional value at risk, for Cornish-Fisher adjusted value at risk, we have capital ZSK, where it is equal to this Z that I have also explained in earlier. This is about Cornish-Fisher adjusted value at risk. All this discussion was about the value at risk for single asset. And now for portfolio, again, we have historical value at risk for portfolio. We have parametric value at risk, means Gaussian value at risk for portfolio as well. And definitely we also consider the optimization concept of portfolio. And after considering these concept, we also get we calculate optimal value at risk for portfolio. Then we have liquidity value at risk. In liquidity value risk, we take the concept of spread also. Because if we have higher spread between buying and selling of an asset, then definitely we have a higher value at risk. As the spread increases, we have less liquidity. So to tackle this liquidity problem, we have static liquidity risk as well as dynamic liquidity risk. Now in static spread, we just account the mean spread value, and in dynamic spread, we take account the volatility of this spread as well with the help of this formula. Then the last but not least, that is about marginal value at risk. When in our portfolio we have a number of assets and there is a small change in any asset, it also change the value at risk as well. So that is called marginal value at risk. So all this about basically it was about the value at risk, different methods. In the next video, we will calculate with the help of live data in Excel in Excel by using all these different 10 methods and by using 28 different ways. Thank you very much for watching this video.